It wasn't just textual material that was translated and circulated, but scientific instruments too. The astrolabe is one of the most complex of these machines and these instruments, and also one of the most exciting to consider. So what is an astrolabe? The astrolabe is a handheld circular machine, often made of brass, but also silver and copper, that provides a stereographical perspective of the cosmos. It allows one to read the skies for the purposes of timekeeping, to chart the movement of the sun, the moon, planets, and the stars, and to compute natal horoscopes. And these are just a handful of its uses. As an object, the astrolabe is a circular disc that contains several movable parts with a ring handle attached to the top. We can see that from the images on the screen. The front of the astrolabe, called the mother, is engraved with various gradient markers on the inside and 24 symbols around the edge, marking out 24 hours of the day. On top of the mother sits a movable cut-out plate called a rete, a celestial map that marks out the ecliptic with the zodiac and the fixed stars, and a movable pointer that sits on top of the rete called an alidade. The instrument, as we can see on the screen, also comes with removable and portable plates that are specialized to the latitude of the area, and these plates are then placed inside the mother. The back of the astrolabe can also be used, and it contains various calendars and markers for time and degrees that can be used to chart the movement of the sun. And in the astrolabe we find two parts: the rete, which contains the star map, which is the celestial part, while the movable plates that give us the latitude of the area in which the astrolabe is used is the terrestrial part. Now, in addition to the precise, intricate engravings needed for astronomical calculations, for marking out the degrees of time and scale, which included using script, Arabic, Latin, Hebrew, depending on where it was produced, sometimes containing more than one of these languages, the astrolabes could also be highly decorated with human and animal figures and vegetal motifs, demonstrating the type of intricate work required by artisans and craftspeople who were involved in their production. Now, the astrolabe was first conceptualized and created in classical Greece. The name itself means star catcher in Greek. Knowledge of the astrolabe was then taken up by scholars writing in Arabic, developing both in terms of the astronomical mathematics needed to use and understand the machine, as well as its intricate design and aesthetics. We get a little sense of the history of the astrolabe in Ibn al-Nadim's encyclopedic catalogue. Ibn al-Nadim composed his catalogue, known as the Fihrist or the Index, in the late 10th century in Baghdad, and he provides us with a brief history of this scientific instrument. He tells us in ancient times the astrolabes were plain. The first person to make them was Ptolemy. The first Muslim, he tells us, to make a plain astrolabe was Abiyun al-Batrik. Then the instruments came to be made in the city of Haran. Later, they were distributed, becoming common and increasing in number, so that the work became plentiful for the makers during the Abbasid period, from the days of al-Ma'mun to this, our own time. Now, the physical astrolabe, the instrument, was also usually accompanied by technical handbooks, known as the art and the use of the astrolabe, Kitab Sana'at al-Astrolabat wa al-Amal biha. The earliest of these was composed by the mathematician Muhammad ibn Musa al-Khwarizmi, who worked in Abbasid Baghdad, and whose handbook and astronomical mathematical tables were known in al-Andalus by the mid-10th century. Indeed, it's from al-Andalus that knowledge about the astrolabe, both the physical instrument and the technical handbooks, spread to Latin West and into Northern Europe, first reaching Catalonia, which was under French domain, where we find the earliest Latin astrolabe. From here, knowledge about astrolabes and astrolabes themselves was circulated and created across different spaces in Northern Europe and Western Europe. And in a Christian context, the astrolabe was adapted to thinking about feast days, determining times and the days of feast days, whereas in an Islamic context, an astrolabe was used to determine the times of prayer. Now, to think a little bit more about the transmission and movement of astrolabes, I want us to turn to textual material in particular and to England. In 1150, the Englishman Adelard of Bath writes a treatise on an astrolabe in Latin, and he dedicates this to a young Henry Plantagenet, the future King Henry II. Adelard directs this didactic manual to Henry. He calls him a relative of the king who has reached an age of intellectual maturity and is now, and I quote, willing to study the teachings of the Arabs concerning the sphere of the universe and the orbit and movement of the stars. Here he directs the young Henry to the teachings of the Arabs, noting, and I quote, I shall write down in Latin what I learnt from the Arabs about the world and how to understand it. It is from Arabic learning that Adelard of Bath derives his understanding of the astrolabe, and it's this that he wants to pass on to young King Henry II. 2 centuries later, in 1391, the English poet Geoffrey of Chaucer writes his treatise on an astrolabe, the first treatise to be written in English, written for his 12-year-old son Lewis. He also provides an introduction to the treatise, where he gives us a little sense of the history of the astrolabe, an instrument that has been known in various different language traditions, including the Arabs, where he tells us that the teachings of the Arabs he tells us the astrolabe is part of the teachings of the Arabs, in the phrase that he uses, known to us by the Arabians in Arabic. And here we see, with Chaucer's treatise on the astrolabe, another linguistic shift, where we move from Greek into Arabic, into Latin, and now into English, where English then becomes a newly emerging language of science, deeply connected to Arabic learning.